Hi, good morning. Today is Wednesday, day 16, 16th of December, which means it's also the 16th day of Advent of Code. Welcome to the stream. You might have noticed today we have a different background music. I switched to a playlist that's Synth Wave, is it called, from Beat Streams, copyright-free music, which is from, what's the author? Artist? I think it was Heller, something like that. And I thought I'd switch to something more upbeat for the stream, something more, I don't know, I think it's more fun. Let me know what you think. If you don't like it, I'll switch back. Anyways, at least this has got me psyched up more to do today's puzzle. We're at 16. It looks like the map is we're kind of like on a different island. I'm not sure. Yesterday we solved, we did a memory game, and then we were on our way to the airport, but somehow I think we crossed a different island to that airport. So perhaps now we're at the airport again. So let's see what is going on today. Day 16, ticket translation. As you're walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. We're taking all possible modes of transport this trip. We had a ferry and a bus and a train is coming up. However, the train ticket you were given is in a language you don't understand. You should probably figure out what it says before you get to the train station after the next flight. That's a sensible thing to do. Unfortunately, you can't actually read the words on the ticket. You can't read. Read is bold, so which means it's something important. It has to do with our solution. You can, however, read the numbers, and so you figure out the fields these tickets must have and the valid ranges for values in those fields. You collect the rules for ticket fields, the number on your ticket, and the numbers on other nearby tickets. For the same train service via the airport security cameras, together into a single document you can reference, which is the puzzle input. Okay, so you collect the rules for the ticket fields, the number on your ticket, and the numbers on other nearby tickets for the same train service via the airport security cameras, which we had, together into a single document you can reference. And that's going to be our puzzle input for today. The rules for ticket fields specify a list of fields that exist somewhere on the ticket and the valid ranges of values for each field. As I'm reading through them, it doesn't make much sense to me, but I'm just going to wait until the example to see what is going on. For example, a rule like class 1 to 3 or 5 to 7 means that one of the fields in every ticket is named class and can be any value in the ranges 1, 3, 5, 7. Okay, that's inclusive, such that 3 and 5 are both valid in this field, 4 is not. That's clear. Each ticket is represented by a single line of comma-separated values. The values are the numbers on the ticket in the order they appear. Every ticket has the same format. For example, consider this ticket. So this is our ticket. It's kind of like, it's beautifully decorated with ASCII art on the borders. So we'll have to deal with that, I guess, as well, because we don't need it. But the content of the ticket is inside here. Here, a question mark represents text in a language you don't understand. This ticket might be represented as 101, 102, 103, 104, 301, okay, all the numbers. Of course, the actual train tickets you're looking at are much more complicated. In any case, you've extracted just the numbers in such a way that the first number is always the same specific field. The second number is always a different specific field, and so on. You just don't know what each position actually means. Interesting. Start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Ignore your ticket for now. So, for example, suppose you have the following notes. class 1357, row 611 or 3344, seat 1340 or 4515. Your ticket is 7114. Nearby tickets 7347, and so on. It doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering only whether the tickets contain values that are not valid for any field. That makes sense, yeah? So in this example, the values on the first nearby ticket, 7347, are all valid for at least one field. So 7 is valid for this one, so that's good. 3 is valid for that one, so that's also good. 47 is valid for that one. So yeah, they all pass. This is not true of the other 3 nearby tickets. The values 4, 55, and 12 are not valid for any of these fields. Yep. Adding together all of the invalid values produces your ticket scanning error rate 4 plus 45, 71. Consider the validity of the nearby ticket you scan. What is your ticket scanning error rate? Okay, that's interesting. So let's get our puzzle input. Yeah, it's slightly bigger than the example, just by a bit. Let's save it to our working directory for today. In here, I'm gonna get rid of the last line. And yeah, let's split this to the right. So we have it in here. I'm gonna make this a little bit smaller. And our code for the first part is gonna go in here. I already have the setup code copied from yesterday. What are we gonna do? All the inputs interesting. So I kind of need to go. I can ignore our ticket, so I can ignore the ticket for this part, and I need to have a look at departure locate. No, there's much more fields on this one. There's a zone, there's a wagon, type, train. Oh yeah, price. That's interesting. So we have a bunch of fields here, like 20 of them, and we need to go through the nearby tickets, and it's a comma. Yeah, so each ticket has, I presume, 20 values separated by a comma, and we need to find out a value that is invalid for all of these fields. As soon as we find that, then the whole ticket is invalid. We store that value in an array, something like that, because we need to add up all the invalid values from all these tickets, and that's going to be our answer for the first part. All right, that seems fairly doable. I'll have to parse this input by first splitting because we're going to get the whole input is going to be one large string. We need to split it with a new line, so we get an element for, we get an array, and each line is going to be an element. And then we need to kind of like figure out, we need to get nearby tickets, and we need to get each class as well. And we're going to need to parse these into numbers, and these are going to be ranges. And we're going to have a bunch of if-elses, if I'm not mistaken. But these are going to be really tedious to code by hand. If I have to make 20 if-elses, and then each if-else is going to have, each condition is going to have smaller, bigger than, smaller than, or bigger than, smaller than. Ooh, that's a lot of typing. Can we somehow be smarter about this? Let me go back to the puzzle text. I was expecting our input to be something like this, but that's just, I think, just like for illustration purposes. Each ticket is represented by a single line of comma-separated values. The values are the numbers on the ticket in the order they appear. Every ticket has the same format. For example, consider this ticket. What do they mean by in the values are the numbers on the ticket in the order they appear? I have to understand that. Every ticket has the same format. Every ticket has the same format. Alright. For example, consider this ticket. Here, question mark represents text in a language you don't understand. This ticket might be represented as, yeah, so like this. So this is basically the ticket that we have here. Of course, the actual train tickets you're looking at are much more complicated, yeah. In any case, you've extracted just the numbers in such a way that the first number is always the same specific field. Alright, so that's a clue that we can use, I think. The first number is always the same field, except we don't know which one of these fields, I guess. The second number is always a different specific field. Alright, so what we know is that among these tickets, the first number is always the same field for all those tickets, and the second number is always the same field for all those tickets, and the third one as well, and so forth. But we don't know which of these fields, so it's not per se that the first number corresponds to the first field, the second one to the second field, and so on. First number might be price, second number might be class, and so on. We just don't know which field that is. And we might have to figure that out for the second part though. But for the first part, we don't really have to care about that, but it's something to keep in mind. We might use it in the first part solution though. Okay, start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any of the fields. Ignore your ticket for now. Okay, that's clear. It doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any fields. Okay, that makes sense. Alright, let's see how I'm gonna approach this one for today. Because I want to avoid, ideally I want to avoid by writing a bunch of if-elses. It's going to be 20 if-elses with 4 conditionals for each one. Ideally I like to avoid that. So I know for one that all these first fields are for the same all these first numbers are for the same field. Can I somehow, well, that's not really part of the problem. I was thinking like, can I somehow get all these numbers and then figure out which field passes? I can figure out the field by evaluating all these numbers against all fields, and then the field that is most likely corresponding to this value is the field that passes most of these numbers. That's kind of like my logic. But I don't need a field for the first part, so I can maybe save that for the second part. For now, let's see if I can use regexes. Can I use regex to say if this number is between, does it match a range? Can I do range in regex? I'm going to pull up my favorite regex debugger, regex101.com. Set this to JavaScript. What if I do a range? What if I do, what range do we have here? 38, 93. So we have 38, 93. Match a single character present in the list below. Okay, so that's not a range. Meta. We can do characters in the range. Why can't we do digits in range? Should be possible, no? Oh wait, so it is taking the range 8, 9, but the 3 and the other 3 is okay. So I need to group these in a way. Can I Ghoul to rescue regex range double digits? Yep. To match all characters from 0 to 25, we need a regex. Yeah. Oh, so you need to be smart about it. You need to kind of have 2 ranges. matches double-digit numbers. Oh, I see. So I'm not very good at regex, so sorry for that. But I think I can do. This will work. 38 or 30. No, that's not gonna work. So what's our range? Our range is this one. So 33 to 9. Except, so that's kind of like working out, except that 3 has a lower bound of 8. So I guess I can I saw someone solve a previous day of Advent of Code with only regex, and I found something like that similar in that solution. So wait, let me just read this. I think the answer is in here. So okay, that's the easy part. Matching the 3-digit numbers is a little bit more complicated, so we need to exclude numbers 2. Yeah, that's correct. So 1 takes the care of that, 2 matches 2 through that. Finally adds till. So the answer is, oh, I see, yeah. As you can see, you need to split up the numeric range in ranges with the same number of digits, and each of those ranges. All right, but so it's kind of clear to me how to write this regex. I'm just looking at, let's look at the input. How am I gonna transform this string into a regex? I think that's way more complicated than just writing if else's. Because I can't just say regex this, because I need to kind of like say, hey, 3. No, that's too tricky. Okay, so that's not gonna be the approach we're gonna take today. If you have any ideas in the chat, feel free to come up with some suggestions. I might give them a try. I think I'll just have to do if else's. I can't think of anything else. So we have to go through each ticket, and each number, as soon as we find the number that's invalid for all the fields, we need to store that number. Or the other way around, as soon as we find a number that's, so we go for this number, we go through all these fields, and as soon as we find a field that it's valid for, we can consider that number is valid and go to the next one, and so forth. Until we find the number that's not valid for any of the fields, then we can stop. We found the number. Do we know for a fact that each ticket only has one invalid number? Or can there be more invalid numbers for one ticket? By considering only whether tickets contain values that are not valid for any field. In this example, the values on the first nearby ticket are all valid. This is not true of the other 3 tickets. It doesn't say. I think a ticket might have more than one invalid value. Yeah, it doesn't really say. So we can't assume that. So we need to go through all the other numbers. Well, yeah. Okay. Will I really have to write an if else for each line? That's really tedious. Oh, but wait. No, I'm gonna parse this. I'm gonna parse these. I'm gonna put them into an array. Okay, so something I know for each line is that each line has kind of like an OR statement and 2 values on both sides, each field. So that's a fact. Another fact is that so the left-hand side and the right-hand side both have a lower range and upper range, like this, for all of the fields. So this is what I'm gonna do. I'm going to parse the string into, and I'm going to extract these 4 numbers. And these are going to be the lower and upper bound of the left-hand side and the lower and upper bound of the right-hand side. And I'm going to do that for all of these 20 fields. And then as I go through the number, I'm going to go iterate through each field, and I'm going to have one if statement, one conditional that just says, hey, is this number between these 2 numbers or between these 2 numbers? If that's true, then it's a valid number. Go to the next one. If it's not, go to the next field and do the same logic. Grab these numbers. So is it between these or these? Yes. Then go to the next number. Otherwise, go to the next field, and so on. So we don't need to have 20 conditionals. We just need to have one, as long as we are smart about extracting these numbers into kind of like an array that we can loop over and use that in a conditional. All right, so let's do that. I'm gonna make this smaller here. First, let's parse our input. All right, const. I'll need to. I'm really digging this music so far. It's nice. So I split it by new lines. I have a bunch of arrays. What I need to do let me see. Can I just hard code it? Not sure. No, I can't hard code it because, yeah, it can be different. Cannot do that. Nope. I'll have to somehow. So I have a bunch of arrays here, and then I need to first. Oh wait, something else I know is that the fields, the ticket, and the other tickets are split by an empty line. So let's first split by that. Then we're gonna get 3 elements in our array. This part at the top, this part in the middle, and this part at the bottom, which is awesome. And then we can name these. We can use array destructuring and instantiate 3 variables, and we're gonna call them fields, our ticket, and then nearby by tickets. There we go. So, and then we're gonna have to do a bit more parsing. So our fields, or the fields, let's split them by a new line. Can't type, new keyboard. Split new line, and then we have an element for each field. And then let's split the field by colon space. Yeah, this is a really neat feature of the IDE. I'm writing using VS Code. You can like select anything, and it's gonna highlight other occurrences of whatever you selected. So by selecting colon space, I can see, oh, let's see, all the fields have colon space, so I can use that to in my parsing. It's really neat. So I'm gonna have a map field, and I'm gonna split that field by colon space and return that. So each field is gonna have 2 array elements, this one and the last one. We can, yeah, we don't really care about the first one, we care about this part. Let me put this map in a, let me put this map in a multiple line. No, do not override it. Awesome. Okay, so that's basically the same. And what I want to do here is this? No, I'm fiddling around. Okay, so what I want to do is we have the field split there. I need to grab the first let me think. I think we might need a field for the second part of the puzzle. So we're gonna need the first and the last part. So we're gonna have to return an array. Okay. What do we need to have? We need to have field name. And we need to have field boundaries. Let's call that, yeah, let's call that field boundaries. And let's split the field in here. By colon space, okay, and therefore we can wrap these in brackets and we can put field boundaries in here, get rid of this line, and then we're gonna need to parse each of those. The partial location, no, the field name is good. Field name is gonna be whatever is before the colon, so that's good. But the field boundary is going to be a string like this, so we need to get 4 numbers. So let's have these in let, because I'm gonna map field boundaries again. No, I can't use map. I need to split it first. Split by a space or space, because we know, again, if we select this, we know all the fields have that, so space or space. And then we're gonna have 2 arrays, and we need to split this one by, again, by space. So we're gonna map field boundary, return field boundary split by a dash. So I think now we're gonna end up, this is gonna be an array. Field boundaries is going to be an array with 2 array elements. This array element is going to be a 2-dimensional array, which I want to avoid. I just want to have a 1-dimensional array. I think I can use flat map. I can use flat map to kind of like flatten the array out while I do the mapping as well at the same time. I haven't used flat map much. So it's not that intuitive for me yet. Returns a new array formed by applying a given callback function to each element of the array and then flattening the result by 1 level. It is identical to a map followed by a flat of that 1, but slightly more efficient than calling those 2 methods separately. So let's look at an example. Here's an array. Flat map returns an array for each element, but then it flats it out. So okay, that's what we need, because this returns an array for each element. So yeah, I think we can just replace map with flat map, and it's gonna do the trick. And then at the end, let's also typecast, because we're gonna get strings. So let's typecast strings into a number, and this is just a shorthand of passing the argument to the number function. And then here we return the field name and field boundaries. All right, this kind of looks good. We did a parsing for the fields. What do we call them? input fields are ticket nearby tickets, fields. Let me rename this to unparsed fields, and then we can assign this to const just fields, because we're going to reuse this variable everywhere, and I prefer this variable to have a shorter name, because I could just name this parsed fields, but then we have to parse fields everywhere. So this is better, unparsed fields, and then we have the fields. So let's run the debugger at a breakpoint here and see what we get. Fields is nice. This looks good. So we have an array of 20 elements, and each element is an array with the first element being the field name, and the second element is another array with the boundaries, 4 of them, and that repeats for each field. Field name, boundaries. Awesome. Really cool. So we've done that. What else do we need to parse? We can ignore our tickets for now, nearby tickets. So let's look at nearby tickets. We're gonna have, this is gonna be an array. So let's split it by again, let's rename this unparsed. Unparsed nearby tickets, and then we're gonna have const nearby tickets in here, and we're gonna say unparsed nearby tickets. So that's one large string that we have here, so we need to split it by a that's interesting. If I split by a new line, we're gonna get first element is gonna be, maybe we can split by a colon space first, and then we're gonna get the field name in here and all the tickets in there. And I think we can use array destructure again. We can discard the first field, we don't need it. And nearby tickets is gonna be that, nearby tickets, the second part. And then this is gonna be a large string. We need to split this by a new line. And then we're gonna have an array of tickets. So I guess I can just do a map. Map. Yeah, the thing is, if I do a map, it's gonna go through this as well. What I can do is, since I don't need this at all, I can put that in here, and I'm basically saying split. Let me run it in a playground and see what we're dealing with. I'm gonna spin up cron.js. What do we have? So we have this kind of like string, and it's gonna be new line, and it's gonna be new line as well. So what if we do split nearby tickets? What does that give us? It gives us an empty element, and then it gives us a new line. I see. Yeah. Wait, what I can do is I can just split by new line, and then we're gonna get a bunch of elements, and that's fine. And I need to discard the first one, but I need all the remaining ones. and that's fine. I think this is gonna work. Let's make this a bit smaller. This is gonna work. Let me first console log it and then I'll explain it if it works. Otherwise I'll feel silly explaining something that doesn't work. Nearby tickets. Why doesn't it? Let me remove these from the watch. Where's nearby tickets? Oh, here it is. Length. Oh yeah, so it works. Okay, great. That's what we need. So what is happening here is basically I'm splitting the string. Let me make this smaller and this bigger. Okay, so I'm splitting this entire string by new line. So the new lines are here at the end. So we're gonna get the first element is gonna be this. The second element is gonna be that. Third is gonna be that, and so on. And what I'm doing here in the array destructuring is saying the first element is here. So the first element we could assign it to whatever. And whatever variable is gonna be assigned to this value. But since we don't assign a variable, we can in JavaScript you can have like nothing here and then comma, and it's just gonna discard that value. You're not gonna use it. It's not gonna assign it to any variable. And then what we're doing here is you say, okay, all the other variables or all the remaining values or elements in that array, spread them out over this variable. So this variable called nearby tickets is gonna have all these elements. It's gonna be an array with each line as an element in that array. So that's kind of like what's happening here. I hope I explained that a bit clear or not. Let me know in chat. Otherwise, I'll try to explain it a different way. That makes more sense. Okay, so we have the tickets and we have the fields. Can we now go to actually solving first part? Are we done with the parsing? We're gonna need to split each ticket by a comma to get the individual numbers. Let's do that here. Map ticket return ticket split comma. Great. All right, let's get to the solving, to the fun part. So our logic is going to be okay, first we need to store our invalid values. Okay, so we need, for each ticket, we need to kind of like filter out the invalid values. So we can say nearby tickets is going to be can I use a flat? I'll try and use a flat this time. Don't use flat that much, but flat ticket, and then wait, what does flat do? Creates a new array with all super elements concatenated. Interesting. I could also do it a bit more imperatively and have a sum variable and keep track of the sum, and as soon as I find an invalid value, add it to the sum. I'd rather stick to functional programming if I can. Okay, let's first deal with the individual ticket. So we know that when we have our ticket, we're gonna have to use a filter. What do we call those? Is that a number or a value? Value. Okay, let's call it value. And we're gonna have our logic for the value in here. So this is gonna return an array of invalid values for each ticket. So what we need to do is we need to flat it out. Actually, yeah, that's what we need to do. We need to flat it out into a big array, and then we're gonna use a reduce to calculate the sum of those. Yeah, I'm gonna add the sum logic in here already, so we have that. going on. Accumulator plus value can be 0. Great. And that's going to be our answer for the first part. So we can assign it to a variable called sum of invalid values. Let's put this to a new line in here. All right, and let's go ahead and already console log our answer. Answer part 1 is going to be in here, sum of invalid values. Good. Okay, let's get back to our logic in here. So we have each value 475 in this instance, and we need to go through each field. But as soon as we find, let me think, filter, yeah, it needs to go through all of them. So value, we need to stop as soon as we find a field in which that value is valid for. So we need to do a sum. Sum is going to break out. So let's say value, let's say fields, sum, field, return. Because sum returns true if any of the fields are valid, and if all of the fields are invalid, then we're gonna get false, which is actually what we want. So we need to negate this. Yeah, we need to negate that. What if instead of negating, I just use every, because kind of like that's the opposite of sum. Test whether all elements in the array pass the test implemented by the provided function. Does it short circuit if it doesn't? The every method executes the provided callback function once for each element present in the array until it finds one where it returns falsy. Oh, but that, no, okay, no, that's gonna mess up with the logic. So no, we need sum. We need to go through each field, because if this is false, then this can be true. So we need to keep going until, let me read the docs for sum as well, so I make sure that I'm doing the right thing here. Test whether at least one element in the array passes the test implemented. So if none of the elements in the array pass the test, if none of the fields pass the test, then it's going to return false, and we negate that. Okay, that looks good so far. So for each field we have, how does a field look like again? It was the name, field name. Okay, so the first element is the field name, and the field boundaries are in the second element. So let's do that here. Array destructuring, we don't care about the first one. Field boundaries, there we go. So we have the field boundaries, going to be 4 elements, and we know that the first two, this value needs to be between the first two or the last two. If value is bigger than, you know what I'm gonna do? I'm gonna make this a little bit more readable by destructuring field boundaries into individual boundaries, because if you like wait. So what I've noticed from my experience, if you're programming and you're tapping into, so let me write it out and show you what I mean. So if value is bigger than field boundaries, the first element, and value is smaller than or equal, you know that, or equal, field boundaries, the first element, and then we kind of like, or value. So like what does this mean? Well, what is this value? What is this value? So whenever an element in an array has a specific role, so here we know that the first element in this array is the lower bound of the first half, and the second one, so whenever it's like it has a meaning, I assign it to a variable and use that variable instead. If instead, like for example, if the array is just a bunch of tickets and each ticket has the same semantic meaning, so like each element has the same semantic meaning, meaning that the first element in the array is a ticket, and so is the 10th, and so is the 15th element in the array. So all of them are tickets. So then you don't need to assign them to an individual variable. But sometimes you get an array with a finite amount of elements, like in this case we have 4 elements, and each element is kind of like represents something, a boundary. So that's when I kind of like default to destructuring to make it more readable. So you're gonna see here that we're gonna replace this with more readable variables in a bit. So lower boundary, field boundaries. All right, so we have them 4. So what do we call them? Lower boundary. Kind of like this, and then oh, why doesn't this work for me? Somehow, for some reason, it doesn't work. Okay, so here lower boundary, second half, upper boundary, second half. This is the best I can come up with right now. I could have named this lower boundary and this upper boundary and this kind of like middle boundary, first and second half, but no, I'm just gonna stick to this. So then I'm just gonna use these variables instead. If value is bigger than the lower boundary of the first half or equal than that, and smaller than that, let's wrap these in parentheses, and then we're gonna have the second conditional here, and another parentheses, and then we can say if value is bigger or equal than the lower boundary of the second half, and value smaller than or equal upper boundary second half, then we found a valid number. Okay, let me get the logic here right, because I'm starting to get confused. So some, at least one element in the array passes the test. Okay, so this needs to be false. This needs to be true if the value is invalid. So we need to negate this. It needs to be the opposite. Let's just say if value is lower than lower boundary and value is larger than upper boundary, or value is larger and value is smaller than lower boundary of the second half, or value is larger than upper boundary second half. this is what I want. Let me just see if I can make this a little bit more. A little bit more readable by. So here's our logic. If values be below the boundaries, below the smaller one, then we know it's invalid. If value is between these two, then we know it's invalid as well. And if the value is smaller than the upper boundary of the second half, it's invalid as well. And then therefore we return true because we found the first element. So in here we kind of like write it by shorthand, return this. And I hope this is readable. I could extract each condition into a conditional into a variable and say is value below lower bound, and then this will be is value, and then use those. But no, I think it's fine. This is good enough. Okay, so we have that. Do we need to do anything else? No. Let's give our program a spin with the example input. So I'm gonna create a file, input2.txt. I'm gonna copy the example input here. This is the example input. Yep. That's good. Copy it in here. Let's split this to the right. I'll actually put it in here. Good. And let's run our program with this solution and see if we get the right answer. Node day 16 index.js. What's happening here? Answer part 1. Okay, so that's obviously not correct. Am I not typecasting these into numbers for some reason? That could be the case. No, I am. These should be numbers. And oh wait, I know what's going on. It's returning the entire ticket instead of the numbers. So I need to fix that. Field sum. Okay, so ticket filter shouldn't be filter, but it should be a okay, wait, so fields, I have a bunch of fields here, right? Yeah, so these ones no, value. Yeah, it should be a filter. I'm returning, so value, and then I'm filtering it out. Yeah, and then I filter out the ticket. Let's add a debugger here, perhaps. Let me just add a debugger here and see what the end result is like. Well, we already logged it, but yeah. So that's a long string. That's incorrect. Let's add another debugger for each ticket. Another breakpoint, I mean. That's interesting. Why didn't it break there? Maybe here? What's going on? Maybe I need to wait, what is nearby tickets? It's an array, isn't it? Let me make sure. Nearby tickets. Nearby tickets is an array. Oh, so these values are strings for some reason. Oh, I see. I typecasted the field boundaries to numbers, but I didn't do that for the values in the tickets. Okay, so this is going to be a string. So I need to flat ticket filter value. Yeah. What I'm gonna do, there's a bunch of noise coming from the outside. I hope it's not too disturbing. Is it disturbing? No? I can try and shut down the ventilation shaft if it's too much noise. So this is a string. I need to typecast this to a number. I want to avoid doing that for all these values in here. So maybe I'll just do it in here. Value number. I could also wait, I can be smart about this, and I can do it ticket filter. I'm gonna add a map ticket. Oh, wait a second, we're not splitting it by comma, are we? Or we are. Nearby tickets. Yeah, we are. Okay, what I can do here is I can do the typecasting here. So that should work. That should work. Nearby tickets. Not a number. Because ticket split. I see why. Because, yeah. That's not gonna work. Nearby tickets. No, I can't do that there. Each ticket, and then ticket is an array of numbers. Yeah, I can do that in here. Map number. Okay, this should be good. Let's add a breakpoint here. I wonder why it doesn't go in there for some reason. Nearby tickets, flat ticket. I mean, let me see. Does it even execute flat? It does. So what's nearby tickets? That's an array of arrays. Yeah, so it's an array of tickets, and each ticket is an array of numbers, of values. And I flat it out, and I say ticket. Ticket map. Why? It's very interesting. It doesn't even go in here. Why not? This baffles me. I have no idea what's going on. Wait, let me first add a breakpoint here. It doesn't go there. Let me get rid of this one. It doesn't go in here at all. Flat. So flat, something's wrong with flat. Flat. You call flat on an array. Oh wait, flat doesn't accept a callback function. It accepts a, what does it accept? I need to use flat map. That was my mistake. flat map. Okay. Yes, now we get in here. Ticket is a bunch of values, and then we map those values, which is good. And then we use filter. Okay, let's see what our program does now. We get this very large number for our own input, which might be correct. Let's see, for the example input, we get 0, so that's not good. Input 2, we get 0. And what's the correct answer for the example input? 71. So let's figure out debug. I'm gonna add a breakpoint. Here and here. So on our first iteration we have 7, which is this value, that's 7, value 7 of the first ticket. Where's ticket? Can I closure fields? No, that's interesting. Okay, 7, and then sum. So for each field boundaries 1357, 1357, value is 7. So therefore, let's see, 7 is valid, so we should go okay, so that's not right. It goes through the other field, and we should short circuit it. Sum, yeah, we should short circuit it. Let me see. Okay, this should be reversed, because otherwise the short circuit is not going to happen. So let's do that. If value is bigger or equal than lower boundary first half, and value is smaller or equal upper boundary first half, and then here we're going to have an or. Value is bigger or equal than lower boundary of the second half, and value is smaller or equal than the upper boundary. Okay, let's wrap these in parentheses so that we are sure that the precedence is what we expect it to be, because I had a bug in that 2 days ago with the bitwise operators. Apparently A or B and C is not the same as A or B and C, because AND takes precedence over OR, so therefore this is evaluated first before this, and I assumed they were just equal in precedence, so that would AND were OR would be evaluated first. So I had to wrap this in parentheses, so I'm not making that mistake again. And therefore, so it's going to return true, it's going to short circuit, and we need to negate that. So that looks good. Let's run the program with the debugger again. Value 7, field boundaries are there, so we should go to the next value. Value 3, awesome. It does what it should do. 3 is also valid, so it should go to the next value. 47, is it? Yeah, it's also valid. So it should go to the next ticket. Oh wait, it should go to the other value. It should go to the other field until the last field. Yeah, we're at the last field. And here it's valid. Therefore, okay, so in here we have 40. 40 is valid for the first field. Oh no, for the second. Okay, so go to the next value. 4 is invalid for the first field. Go to the next field. Yep, we're at the next field. Is it also invalid for that field? Go to the last field. Here it is. And it's also invalid for that one. So it should return, let's run the code. 71. Hey, that looks promising, no? 71. Yep. We might have the correct answer here. I'm gonna run the program with our input and see what the answer is. This big number here, not that big compared to other days. Let's give it a try. We solved it! Bam! 1 gold star closer to saving your vacation. That's reassuring. We have 31 stars in total now. Let's get on to the second part. Are you as excited as I am? Cody Co is also excited. Yes. Join in on the party. Woo woo woo. Celebration Des. All right, let's get to the second part. I'm sure this one is going to be much harder because we're going to have to do something with the fields. We're going to have to determine, my guess is, I haven't read the second part yet, but my guess is we have to figure out which field this number belongs to, which field the second number belongs to, and so on. So let's see if that's indeed the case. Part 2. Now that you've identified which tickets contain invalid values, discard those tickets entirely. Okay, so we can get rid of those. Use the remaining valid tickets to determine which field is which. Okay, so because we discarded invalid tickets, we can go through to the first element of each ticket, and we need to find for which field passes all of the values, all of the first values of the first tickets. Then we have that particular field for that number value. Using the valid ranges for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. Yeah, if seed is the third field, it is the third field on every ticket, including your ticket. For example, suppose you have the following notes. Is this the same example as in the first? No, it's not. It's a different example. Based on the nearby tickets in the above example, the first position must be row, because 3 is valid for row, 15 is also valid for row, and 5 is also valid for row. The second position must be class, because 9, 1, and 14 are valid for class. And the third position must be seed, because 18, 5, and 9 are valid for seed. That's correct. You can conclude that in your ticket, class is 12, row is 11, and seed is 13. Once you work out which field is which, look for the 6 fields on your ticket that start with the word departure. So this is our ticket. The first 6 fields start with the word departure. So look for the 6 fields on your ticket that start with the word departure. What do you get if you multiply those 6 values together? All right, so our answer for the second part is going to be, we need to figure out the values from our ticket that correspond to the first 6 fields. So the fields that start with departure, field names that start with departure, and so on. And then as soon as we extract those 6 fields, we need to multiply them, and then we get our answer. Awesome. Let's do that. Let's do that. Doesn't seem too complicated. Should be able to get it done within a reasonable amount of time. All right, so we're gonna have to reuse. Let's get rid of our example input from the first part, because yeah. We're gonna have to reuse some stuff from the first part, because we kind of have we have our filter. We're gonna have to use the filter, because we need to our first task is to get rid of invalid tickets. Yep, we need to get rid of invalid tickets. Let's do that. So we have nearby tickets. We're gonna say const valid tickets is nearby tickets, filter ticket. How are you liking today's puzzle so far? I'm really enjoying it. It's much better than one of the previous days. It was about that was a tough one as well. Which one was it? I think it was day 13, second part. Yeah, the bus IDs. That was a really tough one. I had to use the Chinese theorem, remainder theorem for this one, but you could also solve it a different way I found out later, which was much more elegant. But I didn't like that one that much. I guess I prefer a puzzle that's a bit challenging but not out of my league. Because if it's something that is like, I have no idea how I'm gonna approach this, that makes it too complicated for me, and then I cannot enjoy it that much. Codigo says, I'm not doing Advent of Code this year, spending time on side projects instead, and it's also too hard for me. It's definitely challenging, yeah, for sure. I must say the first days were not too bad, but the first really tough one was day 10 for me. And the first very few days was okay, but I guess it depends on your level, that what you find difficult and what you find not that difficult. But well, glad to have you here and watch along with me how we solve this. I hope you learn a thing or two. What are you working on? What side projects are you are you working on? Ticket. Okay, so I have a ticket here. Valid tickets. So I think we can just copy some of the stuff here, right? Flat map. Well, we're doing all this logic for the first half. I'm gonna copy this just so I can see it here, and then let's remove, we need to map still, and then we need to filter, and then we need to filter value. No, we don't need to filter value, we need to say every value needs to be valid. Is this let's see what this gives us. I only add a console log here because then I can just add a breakpoint. I haven't figured out yet how to add a breakpoint on an empty line, or can I add a breakpoint at the end here? No, I haven't figured out yet how to add a breakpoint on empty lines, so that's why I'm adding a empty console log here, so just can use that line as a breakpoint. So what's valid tickets? Ooh, no valid tickets, so that's not good. Every value sum. Oh wait, I need to not reverse this. Yeah, this shouldn't be reversed because we're looking for valid tickets now, not invalid tickets. All right, this looks promising. We have 190 tickets. I'm just gonna assume those are valid tickets. Yeah, I'm not gonna go through them because our original input had 245 tickets. So that's 55 tickets that are invalid, which we got rid of. So that's good. All right, I'm gonna stick with that. I'm pretty happy with it. Last year I got stuck on not understanding the premise of a question. Yeah, that's I've seen. I'm doing this with a couple of friends, and they've been working, like they had a bug, and they spent like an hour or more on the bug, and the bug was just because they didn't read the question carefully enough, and they misread a word, or the program was valid, but then they misread what the answer should look like. So maybe here, for example, instead of multiplying, they would do something silly like just adding them together, something like that. So reading carefully is definitely one of the skills that you need to, not so much a skill, but you just need to be careful about what you're reading and what the puzzle is expecting from you. Yeah, I'm working on a type racing application for programmers. Ooh, interesting. Feel free to link it in the chat. I'd like to have a quick look in the stream and perhaps later on as well. Sounds interesting. Type racing application. So is it like who can type the fastest? Like who can type programming the fastest? That'll be interesting because recently I bought a keyboard. It's a split keyboard. Let me take it out here so you can have a look. It's like split into halves, and the benefit of this is that instead of like hunching over your laptop or keyboard, you can just like open up your chest and like sit and type in a more natural position. And so I'm really digging this. I'm going to the physiotherapist, and I've been having a massage on my left, on my shoulders, and my shoulders were really tense. They were hurting a lot by with just a small amount of pressure. But after getting this new keyboard, I just went to my physiotherapist yesterday, and she was like, "Hey, I'm adding a lot of pressure on this part, but you're not sensitive there at all." I was like, "Yeah, this muscle is much more relaxed now, the shoulders." So I'm really happy with this keyboard. So it works, but because the layout is a bit different, I had to get used to it, and I was looking for a type practicing game or like something to practice my typing, my blind typing, and especially related to programming and like cursor navigation, so up, forward, back, beginning, end, stuff like that, like multiple selection, moving line up and down. I'm still struggling with some of these, and I couldn't find it. So were you working on something related? Yeah, do share when you deploy it. Yeah, that'll be send me a message on Twitter. I wanna have a look. So you type certain open source coding snippets, and we keep track of progress with WebSockets. Yeah, cool. So a socket implementation, nice. I want to get a split mechanical keyboard. Yeah, the split keyboards are quite a trend these days, especially the mechanical ones. Some people really get fancy with them. They can cost up to several $100s, and you can get fancy with different colors. You can reprogram them. Yeah, I considered that, but this one costed me about $100. I wanted to try the split method first before I commit to something more expensive. So yeah, I might get the mechanical keyboard later on. But what I like about this is it has a flat structure like the Mac keyboard on the laptop. So I like that. All right, so we have here we have our valid tickets. All right, so let's go to what is the question asking us. We need to figure out the fields. Okay, so how are we gonna approach that? What I need to have is the first values of all the tickets, because then I can iterate through those. Yeah, I kind of need to restructure my array differently, because now I have an array of tickets, but I'm not going to iterate through each ticket. I'm going to iterate through each first element of every ticket, and then each second element of every ticket, and so on. So I kind of need to rearrange my array. I know Lodash has a zip method to kind of like rearrange the elements of an array, and I haven't used any external libraries so far in Advent Code. I try to do this as much natively as possible as I can with native methods, but let me see. But I might have to do it for this time, or I'll just have to do the zip myself. Can I do that? Is it straightforward to do it? I don't want to spend too much time on that, on something that I can just import the library and have it do it for me. But if it's a few lines, if it's gonna take quick, then I might just do it myself as well. So then I solve. It'll be great to, by the end of the event, to be able to say, hey, I solved Advent of Code 2020 entirely with JavaScript native methods without any help from external libraries. That'll be cool. But it's not a requirement. We have our, what I'm gonna do, I wanna visualize it because it's not visual enough for me. Valid tickets. So we have an array of arrays. So we need to convert this into an array that has also arrays, but each element in that array is gonna be, so we need to convert it in an array with 20 elements. And each element is gonna be an array of the first numbers of every ticket. And 20 elements because we have 20 fields, 20 numbers in each, okay. So can we use, do we have to use reduce, or which method can we use here? Reduce is a bit ambiguous. Can I use map? No, because map is always going to return the same amount of fields. And since we are going from 190 fields to 20, that's not gonna cut it. Filter is doing something else, it's not mapping. I can use flat map, perhaps. Flat map, is flat map gonna do it? We take an array, return element for a new array, and then it's gonna flat it. No, but that's still gonna return the same amount of elements. Well, if I return an empty array, no, not really. No, we have to use a reduce. But reduce is gonna get really messy if we use a reduce for this one, because we're gonna start with an empty array, and then, but wait, we can have an object. We don't use it. Why don't we use an object? Yeah, let's just use an object and have, yeah, I'm gonna use an object and I'm gonna use a reduce for that. Yep, that's what I'm gonna do. All right, let's have here fields to values, for lack of better naming, and then that's gonna be valid tickets, reduce ticket. Our accumulator is gonna be an object, and then here's gonna be the accumulator. Well, let's name these fields to values. And then we can say, let's instantiate this. All right, let's instantiate our reduce with first field, second field, and so on. I'm gonna use the index in a little bit. Let's not do that. That's too much work. Nope. That's too much work. I can use the index as the key, and I can just say, let's add this here to the top. Let me, maybe it's not that readable. Let me get rid of this left-hand side. Oh, there we go. All right. So what I'm trying to do here is, I need to return fields to values. Actually, the return doesn't do anything. the return can just be a blank, or yeah, fields to values. But what I need here, why doesn't this work? I have a shortcut which should add a line at the top, but it's not working for some reason. Just ask the bottom. Yeah. Okay. So fields to values at index should be equal to wait a second. These are valid tickets. I need another loop. Ticket. Ticket for each. Yeah, this is ugly. I hate, no, well, hate's a big word. I try to avoid using for each as much as I can, because for each usually means there's some the function is not pure and there's some mutation going on of a variable outside of this function, which is exactly what we're doing here. But yeah, we'll have to accept it for now. Ticket for each. So we don't need an index there, but we do need an index here. All right, and then why is it complaining? Oh, because here. Okay, so that's going to be value, and then no, it needs to be value concatenated to it. So let me just use concat. Concat is more readable. There's two ways you can concatenate a value to an array. You can use the concat method, or you can use you can do it with the assignment operator, and you can create an array, and you can have that, and then spread, and then index this. So this is equal to this. They do exactly the same thing. What this does is it appends, it creates a new array, it destructures the existing array into it, and then it adds this value to the end. You can also add it at the beginning, which then you would need to have to use a different function. I think it's pop or shift or something like that. But I find this can be a bit ambiguous for some people. They're like, what's going on here? So concat is good. It's clear. And then we're gonna have the issue where concat on the first iteration of that index, concat is not going to be this is not going to be an array, therefore it's not going to be a valid method. So what can we do here? If fields to values index is an array, if this is an array, so let's just say if it exists at all, which I can write into a shorthand, I can already see fields to values index. Does it exist? Then concat it. It doesn't exist, then it's going to be the first time we have we encounter that field for that value. So then for that field, we just say no, this is getting hairy. One-liner. I'm not gonna do it in a one-liner. Sometimes being too clever is not working in your advantage. So concat it. Wait, what does concat do? Does it return any value? Or does it modify the array in place? Concat. Merge two or more arrays. This method does not change the existing array, but instead returns a new array. Okay, so wait, we might have to do. And I think we can use a shorthand operator. I think that's something new in like question mark. Why does question mark equals? Or is it double question mark? That's a positive looking at. JavaScript. Operators. MDN, where's MDN? Never click, if you see W3 schools, never click on it. It's a bad resource. I'm not entirely sure why. They're very good at SEO, they always get the first results, but they have a really bad reputation in the industry. But this, okay, assignments. Okay, this is what we want to have. Assignment operators. We need this one, logical nullish. I wrote an article about this recently because these are new assignment operators in Node 15. Logical or, logical and, nullish. Let's first write it out by hand before we get clever with it. So fields to values index, does it exist? If so, then concat it. Otherwise, this is going to be an array with value. Yep, that's it. So I think we can write this. Let's first run it and see what if it does what we want. Fields to values, something's going on. I think we have an error. Fields to values is not defined, of course, because this is a small t there. Does it work? It does. Let's run the debugger again and see what it is. We have an array of 20 elements, and each element is an array of numbers of 190 numbers, which is the amount of tickets. That looks promising. And then 47, 888, 371. Yeah, looks like we did it. Second element is the second number for each ticket. So 649, 593, 457. Yep, okay, it works. So I think if it's undefined, it's gonna logical and we could use the nullish. Only assigns if x is nullish, which means it's null or undefined. And otherwise, what does it do? Oh yeah, well no, we don't need to use it. No, because otherwise it's not gonna assign it at all. And we need to, okay. We'll stick to this. This is fine. This is good. I'm happy. We have our fields to values. Let's go on. Let's get on with our solution. So what we're gonna do is we're gonna use what I would like to do is we have an object. We have an object with the keys are just the order in which those values are. So 0, 1 to 19. We want to change this from being the indexes of those numbers to being the actual field names. So we need to modify the keys of an object. Let's look for a method that modifies the keys for an object. Not sure there is one though. Not sure there is one. I'm just going to modify the object in place through a loop. Yeah, I might have to do that. So let's we need to loop over. Our outer loop is going to be looping over the keys, and then it's going to need those values. So let's say for const values for an object for of array fields to values, and then we're gonna call entries on this one, and then we're gonna get an array for each field. That's gonna be the index. And all right, so we can discard the first one for now. No, actually we can't. Value position, and then value, and then inside here we have an array of all the first values. So value position is in which position those values are. Can we name it something better? Yeah, this is fine. Value position, and these are values. So let's call this position, just position. So we're gonna get 0 for on the first iteration, and values is gonna be all these first numbers. All these first numbers. So now that we have all the first numbers, we need to go. We need to iterate through the fields. So let's say fields, filter. We need to filter out the field that matches. So we need to go through all the fields. Fields, filter, field. And then for each field, go through all the values. It needs to be valid. So we have our first field here, departure location. We have the bounds. We have the logic for the bounds here. And then we need to say that filter that values every. So all the values need to be valid for that field. Return. And what is valid? Valid means it's this logic. Let's copy this. Paste it in one place. Value is bigger than. Wait. Oh, we have a field in here. We can copy this structure. Yeah, because we're gonna use that, and we're gonna reuse this as well. Awesome. And so if value is within the bounds, the first half bounds, or the second half bounds, then it's true for that field, for that value, and then go to the next value. So if all the values are valid for this field, then return true, and that's going to return the field that we need, and it should return just one field. Therefore we can just use find, so then we stop at the first found field, and const valid field, not valid field, what do we call it? Field for position. And then what we can do is we kind of like, we can have a new array, object, yeah. Because what we need to figure out, because we have our ticket here, we need to figure out which field, which value corresponds to which field, so that we can extract the values that correspond to these fields. So I need to get their order. I could store them in an array, sorted array. Yeah, that seems, how about, what if I do, what if I have a variable here that says ordered fields, or just fields in order? How about that? Fields in order. And it's going to return entries map and then everything in here. So then we have our field, and then we just return this. Return the field, but this needs to be, oh, we can map it later. Let's first figure out if this works. Fields in order. I'm curious to see if this works. I'm just gonna do a Hail Mary and run the program. It errors. Of course it does. Entries is not a function. That's interesting because entry should be a function of an object. Oh, I always get this mixed up, but entries is a function of the prototype object, which takes the argument, the actual object. That makes sense. There. Does it run now? Still an error somewhere else. Values every is not a function. Values. That's interesting because values is, what is values? Position. It's position. Oh, I mixed them up. Yeah. Values is the first argument and position is the second. Okay, let's give it another spin. All right, so it runs. Let's run our debugger. And no, let's remove this breakpoint at the end. Yep. Fields in order. Undefined, undefined. Okay, so we have a bug somewhere. I'm gonna add The This is hard to debug when you have kind of like 3 return statements in here. Let's start with this field. And then let's the console log in here, so then I can just add a breakpoint for that. Okay, so first field is undefined. All right, so our bug is somewhere inside there. Good, we can go a level deeper. And then we can assign this to a variable. Const are all values valid. Console log, wait, and then return that. Return are all values valid. Add a breakpoint in here. Okay. Are all values valid? What is find so which field are we in? We are at first field. All right. Values is a bunch of those values. Oh wait, let's typecast this to a number again. Oh, we have the number problem again. Values map number every. Okay, I'm just gonna see if that fixed our program. Maybe that was the. Oh wait, I'm not logging fields in order. Fields in order. All right, fields in order is still undefined. Okay, so that wasn't the problem. That wasn't the bug. Let's add a breakpoint here and another one inside. So value is 0. Why is value 0? Why does this array have? Oh, I see. I see. That was it. So values is, oh wait, it errored out. Values and map is not a function. I mixed them up again. Yeah, I think I did. Oh. All right, works now. So fields in order, what's values? Values, all right. And then value is 475. Okay, I'm just gonna see what we get now. Hey, this looks promising. So we get fields in order. We get an array of 20 elements, of which, yeah, the fields are kind of like sorted, aren't they? Oh wait, something's wrong. Arrival location, departure location, route, train, departure. So we have the same field multiple times. That's wrong. That's weird. So means that this tells us that departure location, for example, can be present in any of these positions. Meaning that all the numbers in the 4th position are valid for departure location, and so are all the numbers in the 5th and 6th. I wonder if that's because we got rid of the invalid tickets. Let's see. Discard those tickets entirely. Well, it's bolded, so maybe that's not it. Use the remaining valid tickets to determine which field is which. Okay, no, I don't think that's it, because they explicitly tell us we can discard those and just work with the remaining valid tickets. Using the valid ranges for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. Based on the nearby tickets in the above example, the first position must be row, the second position must be class. So perhaps if we get a field for the first position, then that field cannot be used in subsequent iterations because we already found it. Is that correct? Kind of like, can row be the second field here? 9, 1, 14. It can, but it's not. Okay, I think that's what we need to fix here. As soon as we find a field, that field is kind of like discarded from our list. So what we need to do is we need to modify the fields array on each iteration. So that's what I'm gonna do here. I'm not gonna use functional programming because I can't do that with functional programming, I think. I'll need to create a copy of the fields, and I'm gonna modify those fields. So let's create a copy here. Fields, copy. And I'm gonna use that. I'm gonna use fields copy, but here I'm gonna say while fields copy after we find a field, we need to remove it from the copy so that in the next iteration how do we remove an element from an array? I'm sure there's a cleaner way to do this programmatically, but I'm gonna stick to this approach for now. Index off, and I kind of like create a new array. Yeah, I can do that. Fields copy index of fields. Not sure that's going to return true though. Oh yeah, it is kind of an array. Field index, and then fields copy. How do I modify? Can I modify an array in place by splice? Concept array by removing or replacing existing elements and adding splice. Insert set index 1. Splice. Delete counts. Oh, maybe I can use this without even actually looking for the index. Start index at which to start changing the array. If greater than the length of array, start. Okay. Delete count optional, all of them. Maybe I can just use splice. And then for start, that's going to be 0. For delete count, optional. Item optional. An integer indicating the number of elements in the array to remove. And then how is item optional? The elements to add to the array. Oh, that's not what I need. I need to remove it. No. But I do have the index though. Some sort on shift. No. Pop is similar to that. Pop, push, shift from push slice. Okay, I'm gonna have to use splice, but with the index now. If greater than the length of the array, start will be set to, okay, if negative. So what does this do? Start 1, so now it's January, February, March, April, June. Oh no, that inserts an element. I need to remove an element, slice. Oh, it's ridiculous I have to Google this. How to remove element from array, JavaScript. Wait, I can use filter. Yeah. Of course. All right. Filter field. Field is not equal to. I need to rename this, otherwise there's going to be a variable name clash. Inner field is not equal to field. All right. So find index. Wait, no, that's gonna filters. So therefore, fields copy. We assign this to fields copy. We get rid of this, and then at the top here, fields copy needs to be let. So this is gonna modify the fields copy on each iteration so that we cannot use the same field twice. Let's see. Okay, so what does fields in order look like now? Undefined. Map. Oh, wait a second. I forgot to return. Here what the map is about. Return field. This is Saudi. But I'll refactor later if I can. Okay, there we go. So we have. Still something's amiss. It's working what we as expected, so we don't get departure location more than once, but for some reason for these positions we cannot find any valid field. Oh, I see. Oh, this is more complicated than I thought. Yeah, that's because most likely, for example, departure location can be in this field instead of this field. So our logic of removing the first field as soon as we find it is not correct. We need to keep track of valid fields for each position and then do an elimination from there on. Okay. All right, so I'm gonna remove all this code because we don't need it anymore. Fields copy. All right, reverse, go back, undo. Reverse, get rid of that as well. Okay, so we left off here. So this is gonna return fields in order. It goes to each position. How about find all? Do we have a find all? No? Find the first element. No, I need to do a filter. Okay, let's see what we get now. Because what I'm trying to have is, yeah, This is kind of like, and then I don't really care about the boundaries anymore. Let's just return the name. So field name, filter. How about I do a map after filter? Okay, the map after filter. Let's do that. Map field name, field name. Is this what we want? All right, so this is what I wanted to achieve. We have an array with each number, each position being, oh no, this is an object, by the way. We have an object with the keys being the position and the value being an array of possible fields for that position. And now we kind of like need to figure out which field belongs in which position in order of elimination. So we can go, okay, we can look at all the positions and say which position has only one possible field. And we find position 17 where only wagon is possible. Therefore we can we know that wagon belongs to position, field wagon belongs to position 17. So we can remove wagon as a possible field from all the other positions. And if we do that, then we find that for position 3, we only are left with the train field. So then train must be valid for that. So then we remove train, and then here we have, so that's kind of like we have to go through the object, through each position, and remove each field. And then eventually on each iteration, we're gonna have one field left over for a position, so we can use that field. And at the end, we're gonna have we're gonna end up with one field for each position. That's what I'm thinking of. I think that's the added element of surprise in this part. All right, so let's see how we're gonna do that in code. I got the logic in my head, but now we need to program it. So we have fields in order. We need to modify that. Fields in order. Let's say unique fields in order. Object values. How do you no object values? Yeah. How am I gonna program this? Let's look at our fields in order. Let's get rid of the input. We're not gonna use it anymore. Okay, so this is our fields in order, and we need to loop through each until we find one. And then, okay, let's have a while loop. While let's have another variable here that says let has more than one field. Has more than one field, and that's fields in order values fields filter. Wait a second. Has more than one field, so that's some fields dot length is bigger than 1. I think that's the logic we have here. Fields in order, we can't use sum, so it's an object. No, it's an array. It's an array. Awesome. So what I want to figure out is fields in order. I'm going to modify fields in order in place. So that's good. So if any of the positions, sum of the positions, we can call this is not fields, this is position. Actually, no, it's the index is position. Okay, fields. If any of the positions have more than one field, so field length bigger than 1, then it's true. Then we have then yeah, our array still has more than one field, so we have to keep going. And inside of here, I'm gonna find wagon. I need to find wagon. Oh yeah, so then I just do fields, oh no, positions with one field, and that's going to be fields in order, filter fields, fields length equals 1. That is good. So then we have the positions with one field, and it can be 1. Let's just make ourselves easier. Let's just find the first one. We don't care. Let's find the first one. Position. It's going to be 1 with one field, and then we can actually grab that element, and that's going to be found field for position. All right, and then we can remove this field from all the other positions. So we can do a fields in order. This is going to be a let. Oh, this is so messy, but I'm gonna keep it messy until I find an answer, and then I might refactor later into something more clean, but I'm not going to optimize that at this point, otherwise I'm going to complicate it myself. Fields in order equals fields in order map fields. And then for each field we need to remove the field for position, this one. So for each, again, we have an array and we need to remove an element inside our array. Same problem, don't we? We have the same problem. Okay, let's find the index. So index of found, index of field for position, fields find index. Where inner field, or I can just a field because we already have a different name outside of the scope. So field equals field for position. There we go. We have our index, and now we need to modify. We need to return a new array. We need to return a new array, which is going to be without that element. Slice. Returns a shell a copy of a portion array into new array, start to end. How to remove an element from array in JavaScript? Wait. Again, filter. Right. I can just do a filter here. Can't believe I googled this 5 minutes ago and already forgot how to do it. Short-term memory programmer. Fields filter. Field is not equal. All right. And therefore, so fields in order equals to map. Then we have the fields, and then fields filter. Remove that field. If its field is not equal, then it's true. If field is equal, then this is false. So don't keep that one. Remove it. Return the new array. Then we assign it new here. Okay. And then we can say it has more than one field because we changed this one here. If it does, then continue until we don't. All right. Let's see what happens. Get an forgot this dot here. Okay. All right. Fields in order. All empty values. That's not what I was hoping to get. Field for position. Oh, but wait. Oh, I guess we removed it. Oh, I see. Yeah, we removed it from the current field as well. So we kind of like need to say if field for position so what happened is that we also removed it from the current position. So we need to avoid that. Fields in order we find a field length is equal to 1. So we find the position and we get that field. And then here in this map, we need to, how do you know which position that is? And fields in order it just finds, fields in order, it just finds, so we have an array and then it finds that element, but I don't know the index of that element. Do I need to do a find index instead? And then just say position, and then I can say field for position is gonna be fields in order position, and that's gonna be the first element, kind of like this, yeah. And therefore now I have the position, so if I can say here if position equals to index, which we get here, then just return fields unmodified, otherwise modify it. That's kind of like what I'm looking for. Let's run again. We get an error. What's the error? Oh, we don't get an error. It just takes a lot of time. Oh no. Do we have that issue? Again. Yeah, I'm doing a lot of nested loops and finds and stuff like that. So that's probably not a very efficient way to do it. I knew that. Functional programming is not performant. Thanks for following Codico. Appreciate it. Hope to see you around in next few days as we progress to this event. All right, so functional programming is not performant. I know that, but it's more readable. So now that we hit a performance roadblock, we need to somehow optimize it a little bit. Before I do that, I want to keep track of I want to see how slow the program is. So I want to kind of like keep track of what's the loop that takes most time. Wait, maybe we are just, maybe we got into an infinite loop. Maybe that's the problem. Let's run it with the debugger. We fields in order, we need to keep this value in watch. Other values we care about, not at the moment. All right, so we have it here. So what should happen is that I wonder why train has, because position 3 had more than train. Oh, it's because we removed it already. Okay, so all right, so on the next iteration we remove train from there, so that's good. Let's go over a few times. Okay. It kind of reached the dead end. You cannot remove any more elements. Oh no, you can. Price. It should remove price. Oh, it's not removing price for some reason. I wonder why. Position 2. We're at position 2, route. Oh, but it should, oh, I see what's happening. It should kind of like ignore it. We need to have another array that kind of like fields in order. We need to have another array that removes the elements that we're already done with. So then we don't, because here it stops. So it finds the first element with one field, finds the first position with one field, but we already did route. So that's where it's stuck in an infinite loop because it's already done. So let's create a copy, has more than one field. Let's create a copy over here. Let fields in order copy. And then we're gonna create a copy. Fields in order. This is a neat way to create a copy in JavaScript. And then we're going to reuse this one. Fields in copy. Yeah, everywhere. Yeah. So has more than one field. Okay. Position. Find the position of the copy. Yeah. Field for position. Remap it. Has more than one field, gone. Okay, what do we have now? We have a syntax error. Oh no, we're stuck in infinite loop again. Okay. So fields in order. Oh, now we're not removing any elements. Fields in order, copy some, has more than one field, that's correct. And then fields in order map. Oh, I see. Oh no, that's not it. Fields in order copy, yeah. Fields in order map. fields, index. Oh, and then they have a different index. Oh my god, I'm making this so complicated. Let me add a debugger here. Okay. So first iteration, position 17. Field for position, wagon, correct. Wagon. So what we want to do here is remove wagon, or remove this position from this array. Fields, remove That's interesting. Fields. Okay, so that's index 0, fields, those. Is position equal to index? I think this needs to be the original. We need the original array here. We need to get position of the original array, and then we need to get the field of that original array, and then we can do the changing in the new array. Still an infinite loop somewhere. So that wasn't the bug. Yeah, no, it's not changing. Let's add another breakpoint here. So on our first iteration we have index 0, so position 0, and then these fields. Alright, so we want to remove wagon from this one. So is position equal to index? Nope. Then we removed it by here. Let's add a breakpoint here. Field arrival location is equal to wagon. Is not equal to wagon. That's true. So keep it. Okay. So then we go price, route, train, wagon. Now we're at wagon. Wagon equals wagon. So filter it out, or wagon does not equal wagon, which is false. So then it returns that the new fields for fields in order copy, and then we assign it. So what is amiss? What's fields in order copy now? Why does it still have? Oh wait, I need to do a map. Wait, this can be much easier. I need to map. That's correct. So I moved the wagon from there, but I also need to move wagon from yeah, that's what I need to do. I also need to move wagon from here. So I'm gonna say fields I'm gonna filter fields index equals to position, or not equals. Yeah. All right, so this is gonna move the actual field there as well. And then let me run the debugger again. Yeah, wagon is not here anymore. Cool. Let's run the program. Still not there yet, but we are at least a step further. We'll run it with the debugger. So in our first iteration, why isn't wagon removed? It was removed here and then has more than one field. Yep, so we go into the next iteration. Is it because Here, it's removed here though. Wait, let me run a few more times. Oh no, it's still stuck there. But why isn't this reassigned? Let fields in order copy equals to an array, and fields in order copy equals to a different array. Let me use the first iteration. So this is the original one, and we modified with it. We removed the wagon. Length 19, yeah, we removed the wagon, and then has more than one field is, let's add a breakpoint here for the next iteration. Has more than one field, that's true. So what's fields in order copy this time around? It's this one. Okay, so we're good here. So what do we have? Position 17, fields in order. Oh no, this needs to be copy. See how I get messed up with the copy and the original one? It's and then, okay, so next iteration, position should be 3. Okay, that's good. Field for position should be train, because we go into the original array. That's good. And then we modify, we should get rid of train. For fields in order copy, yeah, now it's 18. Okay, this looks much better, or promising at least. Undefined is not a variable. Where are we? What is this? Fields in order position? Fields in order position. Here. Oh wait, so it returns undefined at some point. Let's keep track of position. Okay, let's go 17, 3, 2, 14, stops. I hope there's nothing wrong with my approach to the algorithm. I hope that's correct, because otherwise, what do you plan to stream after AOC? Good question. I streamed a few times before AOC about. So generally, I write articles and create video content around deploying applications, and it's targeted at Node.js developers, or also front-end developers working with React, Vue, or whatever front-end framework, but like within the JavaScript community. So someone using React, but in the backend using Ruby, that's not really my target group. And I'm writing content for those folks that helps them deploy their apps easier, put them online in production. So anything related to how to deploy an app, or how to manage a server, how to secure a server, VPS, and so on. That's kind of like what I write about and create content about. So I might stream later on. In a previous stream, for example, the stream is not available anymore because Twitch removes them after 2 weeks, the recordings, but I still have it here. I streamed about how you would create a VPS instance and deploy your app, and have a Git hook automatically deploy the app when you push to the main branch on GitHub. So the way you do that, I did that was I created a webhook in GitHub on the repository, and then have that webhook call an endpoint, which was an endpoint on the server. And on the server, you would receive and verify that the endpoint comes from GitHub through a secret, because anyone who knows that endpoint could redeploy your app. So you want to avoid that. So as soon as we verify the endpoint is called by GitHub, which means we pushed a new commit to the branch, We then, on the server, you then fetch the new code, you install any new dependencies, you build the app, and then you restart the app, redeploy the app. So that was kind of like our setup that I went through in a stream. I think it was about an hour or so, 45 minutes. We accomplished that. We had a basic Node.js app. I created a new VPS on DigitalOcean and set up all that. So that was the stream, yeah. So that's kind of like, I'm thinking I'm gonna stream around about those type of that kind of stuff, yeah. Stuff that helps developers deploy their apps. I might do other stuff in the future as well outside of deployments. So just like JavaScript, the language, maybe Node.js, fundamentals, APIs, stuff like that. Generally, it's educational resources, basically. Will I be streaming after AOC or will I refocus? Good question. I haven't decided yet. I'm gonna take a break after AOC for Christmas and New Year's Eve. Gonna relax, reflect a little bit on the past year, and because for me, AOC, streaming every day with AOC is kind of like also an experiment to figure out whether streaming is something that I want to continue doing, or yeah, if it's something that I'm enjoying, and if it's something that I see long term. And that's what I'm going to reflect on after AOC. I'm going to see, hey, how did it go? Did I like it? Is it something beneficial for me and for what I want to accomplish? And so I don't know yet. I haven't decided. It's either going to be, so far it's been nice, so I might just keep streaming. I don't think I'm going to stream daily. That's too frequent for me. It's very tiring, especially now we're 2.5 hours into the stream. We're almost reaching the end, hopefully, but these are long streams. So I'm definitely gonna do smaller streams in length and less frequent as well. So I can't say up front whether it's gonna be every week or every month or so, but I do plan to keep on streaming. I think most likely I'm gonna continue streaming. I just need to figure out the frequency. Any articles on setting up the DigitalOcean with Doku? No, I don't. I might write those. So if you're interested, I might write. What specifically would you want to know about setting up Doku on DigitalOcean? Any specific question or whatever? Have you tried it before? Anything you struggled with? Definitely interested in CI/CD DevOps, so that sounds cool. Yeah, I'm glad you're interested. So yeah, keep an eye on that. You can also check out my website, maximorlov.com. I already have some stuff in there. A couple of notes, Node.js 15. I have some stuff in there regarding Docker as well. A bunch of Docker articles that you might find useful in case you're interested. Let me link that into the chat. That's a smart thing to do. And haven't tried it, so I'm mostly worried about setting up database there as well as managing the database. Couldn't find good pricing for Postgres hosting, so so database stuff mostly, yeah. Okay, so database in relation to Doku on a VPS. All right, let me write about a note about that. Database Doku on VPS and then Postgres. All right, just wrote a note here so I don't forget it. Yeah, I'll try and see. So because you couldn't find pricing for Postgres hosting, so you tried to self-host. You're aware that there's Postgres hosting as a service, so DAS called in the field. Heroku has it. There's also Elephant SQL as well, Postgres as a service. They have reasonable pricing. It's free for 20 megs. After that, $5 for half gig. Reasonable, I would say. I'm heading out. Yeah, thanks for sticking around. Appreciate it. It's a long stream, so don't feel bad for leaving. No worries. Yeah, thanks for interacting on the chat. Appreciate it. Thank you for the good luck wishes. Yeah, elephant looks reasonable. Yeah. All right. Thank you very much, Cody Co. Cheers. Have a nice day. See you around. I'm gonna continue with this until I find an answer or until I get tired because I need to get lunch. I don't want those two. All right, let's get it going. Where have we left off after this brief intermezzo? We are at field for position. All right. So we get position 17. Position 17 and field is undefined. Oh wait, that's executed. Field is 3. Let's remove this one. Position 2. Field for position is route. That's good. Position 14 and field for position is departure time. And then it quits somewhere because it what does it quit? Where does it quit? I'm just gonna add a breakpoint everywhere. Position 17, go, go, go. Oh no, this messes up. So which position was it? Position 3, 2 route. I think it was here. Departure time, yeah, position 14. So let me add a breakpoint everywhere I can. So I have no idea why it quits. Just quits. All right, let's run the program. Undefined is not an iterable. Line 90. All right, so field for position in position 14. Fields in order copy find index. Let's add a comment. Get position with one field. Find position with one field. Find index fields what fields length is 1. So far so good. We get position 17, position 3, 2, 14, and then we crash. All right, so then what do we do here? Fields in order. So we tap into the original one, we get the position, at the end we get the field, get single field for position. So that's what we're doing here. So let's add a breakpoint here. And then for position 17, fields in order, 17 is wagon. For position 3, we get train because we removed wagon. For position 2, we get route because we removed train and wagon. For position 14, we get departure time. You know what's interesting? Position 14 does not have length of 1. So why do we get 14 in this instance? Because 14 wagon, train, and route are removed, but all of these are in here. So it's not length of 1. Fields in order copy. Something's wrong with our mapping here. Okay, what's fields in order copy? So see, here's the problem. Oh, yeah. That's not 14, that's 16. All right, so we get the wrong position. Let's try and fix that. How do I... Instead of removing elements, I should just keep them the order. Otherwise, it's messing up with the position order. So I'm gonna empty the array. So instead of filter, I'm gonna map. I already have a map up here. Okay, here's another map. If index equals to position, all right, I already have a map here. I'm going to reuse it. Yeah, if position equals to the index, return empty element. That's fine. All right, let's see. Let's go through the program again with the debugger. So we have position 17 and and field for the position is wagon, which is correct. All right, and then next iteration position 3, and field for that position is train, correct. Field position 2 and field route position 16, field price. Okay, so far so good. Position 0, field arrival location. Okay, this looks good so far. I'm going to run the program, give it a shot. It still fails at some point, but let's see where it does fail. Let's go further. Position 15 is the arrival location. Didn't we already have arrival location? Yeah, that was okay, so this one should be removed. It should be duration instead. Yeah, field for position should be duration, not arrival location. So somewhere in here we did not map it correctly. Fields in order copy fields, because what was the arrival location? Okay, let me keep track of let's run it again. I'm going to keep track of fields in order copy. So now we removed wagon, and then on the next iteration we remove train. So that's good. Let me add this to watch so I can look at here. So remove, okay, now we need to remove route. That's correct. Now we remove price. Good. And now we need to remove arrival location from here, but also from here. So let's add a breakpoint here just to make sure. So fields arrival location index 0. So we have if position is equal to index, which is true, return empty. All right. Next, this one we don't have arrival location. We do have it, and on the 6th. So fields filter field. There's another loop in here. Field departure location equals. Okay, that looks good. Let's remove it. What is the... Okay, let's... What was our replication? Oh yeah, that's correct. We moved it from there. Okay, so then... Position is 15. Oh, I see what's wrong. Yep, found our second bug. I'm just grabbing the first element. I should do it from, I should use fields in order copy here. Yep, that's what's wrong. Okay, let's run the program again. Hey, we fixed our error. We reached the end. Let's try and let's log the what do we log here? No, let's here. Fields in order copy, everything's removed. Awesome. Fields in order. Wait, this is silly. We're just removing, but we're not keeping track of which field is where. Okay, so let's change this to kind of, we need to keep track of yeah. I'm going to create an object here. Field to, I'm going to name it field to position. And then in here, after we're done, we say field to position at field for position. So that's how we keep track of what field is in each position. Let's see. So field to position, there we go. We have an object with the field name and the field position for each field name. This looks promising. I think we're reaching the end of our puzzle here. So the last thing we need to do is, now that we have the positions for each field, we need to extract the values from our own ticket for all the fields that start with departure. So all these fields, we have the positions. We need to extract these values from these positions. Okay, so let's grab our ticket. Where's our ticket? It's all the way in the beginning. Let's open to the side. Yep. Okay, so here's our ticket, and then we need to get our ticket is in here. Let's split our ticket by a comma. Our ticket split comma. Then we have each. Then we have an array. Yeah, and then we need to multiply. So let's do a reduce product of values, and our answer in part 2 is going to be product of values. Answer part 2 product of values. All right, remove the debug breakpoint here. So our ticket split, we have an array, and then we need to filter value index something with includes index. Then we only have our values, and then we can use a reduce on that value, and then we can say accumulator plus value. All right, so in here we need an array with all of the indexes of those fields, all of the positions of those fields. So let's create it here. Const positions for departure fields. There we go, and there we're going to use this here. And then we need this to be where's our object? Field to position. We need to object entries. and field name. Field name is going to be the first element of the array, and then the second one is going to be the position or field position. Great. Okay, let's get back down here, and then what I want to do is I want to object entries. Oh, wait a second. Object entries. Field to position. Not here. Yeah. All right. Object entries, and then I want to do a filter. All right, and inside that filter I return, oh, I have a syntax error here, and inside that filter I return field name starts with departure. Let me double check that starts with is an actual function and not something I'm making up. String starts with determines whether a string begins with a character of specified string. That's correct. We are looking for departure, and our fields are here, departure. They all start with departure. Good. So then we filtered out those fields, and then we need to map, I think, because we're going to need an array of those positions. So just field to position, field position, kind of like this. All right. Therefore, here we should have the positions of all the departure fields, and then we say, hey, value doesn't include, and then reduce value. All right, let's run a program. We get a weird, that's probably because we're adding strings. So something in here is string, value is string from our product of values. Our ticket split, yeah, we need to split, and then we need to map those to a number. Those are numbers. All right, great. Run again. 882. Moment of truth. Almost 3 hours into the stream, did we get the correct answer? No, it's too low. We're too low. Probably we are off by. Are we off by 1? Let's debugger. I'm gonna add breakpoint there. Remove this one. Remove this one. What do we care about? We care field to position. Field to position. Okay, no, it's not off by 1. It starts at 0, then 19. So then we need our ticket. Where's our ticket? It's here. Oh, this probably was wrong. Our ticket is also has the your ticket string, so we need to get rid of that first. So let's do a dot split by new line, and then the second element of that array is gonna be okay. Let's run our program again. Still 882, but I think now we get the right thing. Let's add a breakpoint here. Then maybe here. So value is, index is 0, value is 139. That's good. Does What's positions for departures? Yeah, so those are all the indexes. Does it include this index? It doesn't. 0 is not in here. Therefore, filter. All right, that looks good. You know what I'm gonna do? I'm gonna comment this out, and I just want to see the array. So we get 131, 239, 109. Okay, let me see if this is the actual. Field to position. There. Okay, so element 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 157. Okay, so why do we get 131 instead of 157? Where's 131? It's here. Oh wait, oh, I think because, okay, so 0, 1, 2, 3, 4, 5, 6. 6, okay, that's in there, and then we get 239, that's 7. That's also in there, and then we get 109, which is 8, 9, 10, 11, 12. 12. Then we get 73, which is 13, yep. Then we get 157, which is 14, and then we get the last one, 173, which is the 19th or 18th, yeah. So that's good, and then we, oh, such a silly mistake. We don't need to add them, we need to multiply them. I figured it out. All right, moment of truth, moment of truth. We get 0. Oh, because we need to start off with 1, of course. All right, this big number should be our answer. Pretty confident about it. Yes, 3 hours into the stream, we did it. Finally, day 16 solved. We got 32 stars in total with 18 stars left, or 9 days. 9 days left of Advent of Code calendar. Nice. Thank you for, let me just, before I wrap this up, let me upload, let me push this code to the repository. I'm gonna add git status. Oh wait, we have our example input in here from deleted. Oh, sure, okay. Git commit day 16 solved. Git push origin main. Let's pull up the our solution here. Yeah, it's not the cleanest solution. I might refactor this a little bit later, but it's working at least for now. So let's verify that we pushed. Yeah, it's in here. Day 16 solved. Awesome. I'm gonna drop a link to the repository in the chat so you can have a look if you do wish so. And yeah, that's about it for today's stream. We solved day 16. Took us 3 hours, a bit longer than I should have. A few silly bugs. Yeah, it's like the last one, just instead of multiplying should be, yeah, a few silly bugs, but we did it in the end, so that's nice. Thank you for sticking around, appreciate it. I hope to see you tomorrow, same time, 10 a.m. Central European time. We're gonna go continue with day 17 of Advent of Code. And if you want to reach out, _maximization on Twitter, my DMs are open, feel free to send me a message. Thank you again, and see you tomorrow. Bye bye.